Hello, this is Greg Allison, Green Greg's, coming to you late night on the 22nd of November, 2020. I've come to you to talk to you about something you've asked for. You asked for this, so I'm going to bring it to you. You asked me, Greg, what happens if there is a solar micronova, or if there is an event like reported by Chan Thomas in the now unclassified CIA book, which is on their site, The Adam and Eve Story, in which Chan Thomas explained what he claimed was a mechanism whereby the Earth would just basically stop rotating, and the ocean would come up out of its basin with a 2-mile-high tsunami sweeping worldwide. Ha, Greg, how do you prep for that? Well, one, I'm going to shoot holes all in this stuff. I mean, I'm going to shoot holes in it. I'm going to back it all with science. But I'm also going to tell you how to prepare. I'm going to tell you how to bug out, because this is a follow-on to my previous bug out video, and I'm glad y'all like that video. You asked me for that in one of my live sessions. You said, Greg, please do a video on bug out locations, what to do. I said, okay. I was kind of planning to do one eventually anyway, so it's all right, time's right, and right now with everything going on, that makes sense. So I did that video, and now I'm bringing you this video because the comments of that video asked for this. So I'm giving you what you asked for. But I'm also going to explain to you some reasons I see things a little different, but I'm going to back it all up with science, with physics, with biology, with geology. And guess what? I have actually calculated the amount of energy it would take to, according to Doug Vogt, evaporate 600 feet of ocean water worldwide. I've calculated that. I'm bringing you that tonight. I'm going to give it to you in joules, and I'm going to give it to you in megatons, and I'm going to give it to you in calories, joules, megatons, and how many Hiroshima bombs it would take to do that. And when I get done with all this, and I'm going to show you examples worldwide. I'm going to show you where to bug out to, and I'm going to back up with geology from why these sites have been safe for thousands of years beyond any such events that they're talking about here. And it's not as radical as you would think. So we got it covered. And I got more good news on top of that. Right now, I got a real special running. It's 4-week supply of food for $100 off. Yes, 4-week supply, 25-year lasting prepper food. Guys, this is your freeze-dried, dehydrated type food. It is lightweight because there's no water in it. And it comes in pouches in here. This is easy to carry. It's not like that big thing when the competitors show somebody struggling to get across the threshold. You get 2 of these. Here, holding my thumb with my pinky finger, tossing it around. It's not hard to move around, but this is 2,000 calories a day. Now I do videos on purifying. I got a video on purifying sanitizing water, by the way. It's my first prepper video, one of them, besides part of the defense. But you get plenty of meals in here, real food. It's not MREs. Go to prepwithgreg.com. Right now, the special is running. The base rate, though, is going to go up in about a week. So I'd go now and get it while the getting's good. It's 8 days and some hours. The time you look at this, is probably a week. Because I may not post this video till tomorrow. Prepwithgreg.com. It's also got many of other prepping supplies in there. Once you click on the My Patriot Supply logo on that page. All right, enough of that. I'll tell you what I'm going to do. I'm going to share a couple things, and I'm going to drop back out of share, and I'm just going to talk to you. I'm going to talk numbers. I'm going to talk physics. I'm going to talk evaporation of water and all kind of good stuff. And then we're going to look at what's happened to the world. We're going to look at examples. And once I've got all my foundation built for what's good and what's not good, I'm going to show you where to bug out. So buckle up. We're going there at your request. So hang on. I tried this a minute ago and actually killed my video. The wrong button. So here we go. Uh-oh. There it is. That's the Adam and Eve story. That's not where I wanted to start with. This is CIA.gov. I'm on the CIA website. There's the story by Chan Thomas. We're going to come back to that in just a little bit in my next share. So what we're going to do is looky here. There is kind of cyclic things going on in the world in terms of ice ages. Bam, bam, bam. That's the interglacials. That's the hot periods. This is the ice ages. cold, windy, snow, blizzards, almost all of our time for the last, over 400 million years. Actually, date back that we're in the Quaternary Ice Age, by the way. We just happen to be in interglacial in the Quaternary Ice Age. That's interglacial. And that's a really brief interglacials. Most likely interglacials have got a little longer, a little flatter, made our life a lot more comfortable. But look at the cyclic nature. Bam, 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 bam. So this chart talks about temperature in C. This is parts per million with the carbon dioxide. Well, that's carbon dioxide. That's dust. Okay, carbon dioxide. I don't get to be. But anyway, look here. This gives you a little better idea of the timing. It's not exactly cyclic, unlike what some people tell you, because look, the time frames are actually decreasing a little bit. Although that one and that one's about the same. Actually, that might be a little shorter. Maybe it's going to increase again. It's variable. It just appears this is not enough sample size here to give a, hey, it's doing this and it's doing that. But over the period, it's been pretty much decreasing till we got about here, and maybe it's holding steady. But it's not exactly set at one set clockwork interval every time. That's important to note. Yeah, we'll come back to little boys shortly. All righty, so what we're going to do here, I'm going to end this share. I'm going to talk numbers. Bam. So Doug Vogt and Chan Thomas both created reports. We're going to talk about the Doug Vogt stuff first. Then we'll talk about Chan Thomas stuff. And we're just going to talk about it overall. And we'll talk about a couple of things. Another idea, kind of a tangent related to Chan Thomas and Doug Vogt, something that you'll see on Ben Davison on Suspicious Observer talking about. So let's talk about water. Doug Vogt, bless his heart. Let me say something. Everyone tries to figure things out, really, in this world. We're trying to figure this world out. We're building our world model, but we take in information according to the worldview we already have. Now, some people have a little bit of advantage when they go to certain problems. Maybe their education helps them or things like that. Well, we all walk in with our prejudices. Now, here's the one thing about human nature you need to understand. Everybody needs to understand this, and we all fall prey to a lot of these things. I've fallen prey to things that I told other people not to do, and I said, this is a problem, and we all have to watch out for this, and I've fallen prey to some of the same kind of things. Is that really okay? Yeah, thought I knew better than that. We have human nature, okay? One aspect of human nature is this. Sometimes we get an epiphany. Now, maybe we get the light goes off in our head. And sometimes it may be that that light is right. But whether the light is right or just bright, it's going to send you out of sight. Essentially, here's what happens. You get an epiphany. Once you get an epiphany, that sets your worldview, establishes your rose-colored glasses. Once that epiphany comes upon you, you begin to interpret everything. A lot of people do. They start interpreting. They hit such an epiphany. This is how it works. And they start seeing it in everything. They start interpreting the whole world according to that epiphany because it sets their worldview. Now, the problem with that is that that epiphany might have been true over a narrow range of whatever case you're looking at. But it usually don't apply to the entire universe. And that's what a lot of people do. They get, they start seeing everything that way. That's their new worldview, and they run with it. And almost everybody does. And it doesn't matter what education level you're at. It's human nature. And people with PhDs and 99 degrees still at their core have human nature. So don't forget that. We're all meat servos. Meat servos? What do you mean, Greg? Well, the servo is an automatic device you put a current to, and it turns something or it actuates something. We're a meat version. Anyway, that's something some of us in rocket engineering like to joke about in my neck of the woods here in Alabama. That's redneck rocketeers. So, hey, you know what? I look good in these, don't I? Take them off. So I lost those. I just found them again. That's not the one I did the original video on, rose-colored glasses. I already lost those for good. So I don't buy expensive sunglasses, my friends, because I lose them. Okay, we're going to, Doug Vogt. I'll get back to this. Doug Vogt was trying to solve a problem, and so was Chan Thomas. Each looked at problems, and they looked at data. They tried to solve them, and they had their epiphany. They came up with an answer. Doug Vogt goes like this. Okay, we had an ice age. The world's cold. The air is dry. Yet we evaporate enough water to deposit 2 miles thick of ice on the continents, North America and parts of Europe, Greenland, Iceland, the Arctic Sea, ocean. How do we do that? How in the world do you get 2 miles thick layer of ice on land during an ice age when it's cold? How's the seawater evaporate? The air is drier. How does it happen? So he really puzzled, and he came up with a solution. He discovered this idea of a micronova. And so his solution was that the sun went into a micronova, and it was so hot that it evaporated 600 feet of Earth's seawater. I don't know where he came up with 600 feet. We're going to go back to that, though. The sea level, actually, at one time, it'd been over 700 feet lower than what it is now, but that was way back. So the time in question, about 12,000 years ago, since the last glaciation, it's actually rose about 400 feet. And you say, okay, great, maybe it should have been 400 feet. Well, okay, but there's another problem. He sees this happening all at once. Like there's this huge flash event that flash vaporizes water on one side of the Earth. He calls it a supernova, a micronova. So, if a nova is how much energy a sun like ours burns in 10,000 years of being released at once, a micronova would be a millionth of that. So it might be about what our sun consumes in a week. So that would fry our planet. But, oh yeah, we're going to evaporate this much seawater? Well, it actually would take more. Let's say you are going for 400 feet, and let's say that we got continents. So all that seawater evaporates. Well, they don't all fall back on the land because the world's 2/3 water. To get the ocean down 400 feet, you got to evaporate a whole lot of water to get it, have enough land on land that it leaves the sea level at 400 foot below. So since the land is about 1/3 of the surface area, if you're going to do an instantaneous evaporation, and you're just doing it on one side of the planet, mind you, that means the whole sea level would need to go down temporarily, I'd say 3 times as much as it went down overall. So, because I'm saying it's falling back in the ocean again, because precipitation is going to be global. It's not just going to rain or snow on the land, and you need snow, not rain, for this to work. And so some of this is going to fall out as rain in the tropical areas because the glaciers didn't cover the world. So it's actually more than what I'm saying, but I'm trying to be generous. So think about it. So you're going to need, if you're going to evaporate 400 feet of water globally, is what the latest statistics say, then if you need 3 times that, you need to evaporate 1,200 feet of water. But it would even be more since you've got to, what? You got to count for it raining and the equator. Hey, south of Mason-Dixon line, we didn't have glaciers. At least, they stopped at about the Ohio River to a maximum extent. So even right here, there was no glacier. It was raining. Or maybe light snow. Which went away. What happened down in South America? They didn't have glaciers down there. Antarctica did. But hey, most of the southern hemisphere is ocean. So what happened? How much ocean water would you really had to evaporate it? I just said 1,200 feet, probably been double. 2,400 feet. 2,400. What would evaporate on one side of the Earth? 2,400 feet of water. Oh, I'm not even going to go that far. I'm just going to go to 600 feet. I'm going to talk about the energy it takes to take 600 feet of water worldwide. And we're going to start this with the little bitty cubic centimeter. It takes 2.54 of them to make an inch. If you line it up an inch, you got to take 2.54. So a cubic centimeter, just a little thing. But that's how the metric system defines energy. And I'll transfer to English systems for us all. So it's up, but since they do such a good job at defining energy in that area, know this: to melt water, iced water, liquid water, takes about 80 calories. Now these are the gram calories. The calories in your candy bar are kilocalories or 1,000 calories. A lot of times you see units in kilocalories. That's 1,000 calories. We're just talking gram calories. The very basics of the System International Measurement System, or what we call the metric system. Now to go from that point to boiling the water, making it come to a boil, not evaporate, making it come to a boil. A cubic centimeter takes, and this is where the definition of metric is all based in, 100 calories. So it's what it takes to take it from the liquid state to the boiling state is 100 calories. To take that to the evaporation state wasn't part of their definition system, but it takes 540 calories to evaporate a cubic centimeter away. I'm going to translate that into 600 feet of ocean. Strap on. 640 calories. Well, it just turns out that a cubic foot, which is actually has, figured out cubes take up a lot of space. You know what I mean? Go work it out. A cubic foot has 28,306.8 cubic centimeters. Okay. How big are the Earth's oceans? The Earth's oceans are 139.4 million square miles on the surface. So if you want to know what the surface area is in square feet, and to get 600 feet, all you do take that number and multiply by 600, okay? So you multiply how much length is in a mile by how much length is in a mile, you get how many feet's in a square mile. So it's 5,280 times 5,280. Multiply that times 139.4 million square miles, and then multiply that by 600, and you get the number of cubic feet that had to be evaporated, according to Doug Vogt. Doug Vogt said we evaporated 600 feet of water. So what that comes out to is this number right here on the top of my notes. That is, wow, 200 and let's see, it is 2,331,749 million trillion with some change numbers in here, million trillion cubic feet. So we're 2 1/3 million trillion cubic feet. Whoo! All right, well, how many cubic centimeters is in that many cubic feet? Well, you just take that number right there again and multiply it. 28,316.8 times your 2 1/3 million trillion. And what do you get? You get like, hang on to this, guys. You get 600, now you get 66 trillion centimeters. Cubic centimeters. Oh, here's the number. Here is that number. Right here at my fingertips. Now you want to multiply it by 640 to find out how many calories it's going to take, because I'm assuming it's all water already, so we're going to ignore the 80 calories to melt it from ice. And probably worth some ice out there, right? We'll ignore that. Well, some of the water would have been a little bit warmer, at least surfacing. Get down deep in the ocean, it's all about 34 degrees all over everyone once you get down to a certain depth. Just above freezing. So multiply times 640. What you get is, you get, okay, that wasn't a 66 trillion, man, it was 66 million trillion. Okay, you get 42 and roughly a quarter trillion, 42 and a quarter trillion calories. That is this number right here. Yeah, a lot of numbers there, right? We're talking a lot of water. All right. So there's 4.184 joules per calorie. So you multiply that time, and you get 176 trillion joules. 176 trillion joules. You see that number right there? All right. So it just so turns that you can figure out how many joules per ton of TNT, which is this number right here. That many joules per ton of TNT. So if you set off a ton of TNT, you've liberated 4,184,000,000 joules. Okay, now I can divide that by this other number of total joules to figure out what the megatonnage is. So what it comes out to is the tons of TNT equivalent. Now, you know, setting off a whole ton of TNT is, it's 42 million trillion. So I divide them, getting the number smaller again, my friends. 42 million trillion. All right, the little boy bomb that went off over Hiroshima was 15 kilotons. So when I divide that number by 15 kilotons, this is how many Hiroshima bombs you'd have to set off. You'd have to set off this many Hiroshima bombs to evaporate 600 feet of seawater worldwide. And that comes out to 2.8 trillion Hiroshima bombs. Have you ever seen the figures of showing how many dollars, how big your stacks would be to be a billion? $1 bills. Imagine a trillion, it's 1,000 times more. A million is incomprehensible almost to most. We hear these numbers all the time, but it's almost incomprehensible. 2.8 trillion Hiroshima bombs. Wow. So the significance of that is that, just think about it. You got half the Earth. Let me show you a picture. That's being hit by something from the sun. Hang on, that's the best way to do this. Way. Pardon me, I only had one color pen working. Oh, my end got wiped out because I was handling that. This is the only pen that's working right now for some reason. Oh, that's right. Yes, it got wiped out. All right. That's that right there. And it's backwards to you, don't it? Maybe, I don't know. So, I'll put the cap back on this pen so it don't dry out. What happens? We usually just think of it geometrically this way, but there is no roll up and down in space, okay? You can lay it out any way you want. But, so you got the sun, and that's not this close on scale to Earth, but on scale it's much bigger, but almost be flat on the scale if Earth was this size, but it would be way off that way. There's 93 million miles between Earth and the sun, okay? So the sun is shooting out all this energy. At 2.8 trillion Hiroshima bombs at Earth. Now, it'd have to be a lot of energy to evaporate 600 or more feet of seawater. Like I said, you know, but it's all going to be in one half of the Earth that this evaporation is taking place. So if it's 400 feet worldwide, you're going to, you know, if it all fell on land and turned into snow, which it don't, it would have to be, you know, 3 times that much, 1,200 feet. But it's got to be more than that because the most of the land didn't get covered by ice. So, you know, what excess of 2,000 feet of seawater had to be evaporated, according for Doug Vogt's vision to take place, as he explained it, as I understand his explaining, which I could be wrong, okay? But it sounds like you got to have an enormous shock wave of energy and evaporate a huge amount of water. So if you're evaporating a very large significant of a mile of water, mind you, water is hard to evaporate. That's why it takes so much joules, you know, 540 to evaporate liquid water, or no, to vaporize it from boiling point once it's already boiling. And water is very resistant to, you know, change of heat. It's very stable. And a lot of temperature would be going down into the water below too. So there'd be a lot of heat loss. What's happening on land on that side of the earth? Rocks would melt, vaporize. Rocks would vaporize. It would vaporize. Soil, dirt, forget about it. Living organisms, you are beyond the roasting point. It would make Venus, the surface of Venus, look like the polar ice caps of Titan, where you have liquid nitrogen. Frozen gases, methane. Continents are made out of methane, solid methane. Yeah, that's the difference. It would be so hot here. It would be unbelievable, unbelievably hot. It would cook things thousands of feet into the ground. I mean, roots, seeds, bacteria that live deep, deep, deep in the rocks would all die. It's okay, Greg. So half the world dies, but the other half's cool. Oh, yeah, it's really cool, but not in a good way. So what happens? You get this kind of energy in here. It's going to get real hot over here. What happens to air when you really superheat it like a fire? And what happens? The air rises. It expands. It's energized. It expands rapidly and starts rising like crazy. You just put a lot of energy in that air. And it's going to form a vortex, kind of like a ginormous worldwide tornado, stronger than a tornado, but covering this whole part of the world. You get a ginormous vortex rising up to what would be like a mushroom cloud, except it's getting beat by the sun at the same time. It'd be rising up, trying to billow out. Anything that billowed past the Earth's limb, the sun would just shuck it off. We'll lose a big chunk of our atmosphere. But what's going to be happening on the other side of the Earth is all this air is rising and getting away and being sloughed off. Some of it's going to be so energetic it'd go to escape velocity. Boom, it'd be gone forever anyway. In addition to the sun sloughing it off. Well, this side of the Earth, you got almost a vacuum over here because all this air has been pulled up. It's going to pull the air from the other side of the world very fast, high winds, enormous, thousands of miles an hour winds, rushing from over here where you got air pressure, 14.7, surface to over here where it's like nearly zero because it's all expanding, pulling away. So what's going to happen over here? You're going to have the atmosphere pressure is going to drop to about 100th of what it is. Everything, because air expands, it gets cold fast. When you expand air, expanding air is how you cool things off. It will freeze. This side of the Earth would just like flash freeze with no air. As this side is baked with no air. When all this is done, there ain't no air. Even if some of it comes rushing back down, and when all this air was gone, all the animals are going to die of asphyxiation because they got no air. So where the heck do you go in this world? Well, there's no geological evidence for half the world baking. Yeah, it would really get half the world. Where's that evidence? Okay, let me just put that as a question. Where is that evidence? Where's the evidence of an evaporation that hot that you would lose the air on? You would lose the air on the other side of the world. It would be gone. It would just over here. One goes over here, it goes up real high. Some of it's gone because it's too energetic. Lots of it would just mushroom and billow out. Maybe as it would want to come back down, but with the sun doing this, they'd be stripping that stuff away. It'd be gone. Our atmospheric pressure would never return to what it was before. We've lost a lot of air. That might explain why creatures a little smaller than they were before. Less air to breathe. Okay. That's a little hard to swallow. But we're going to proceed as if it's not. But that, my friends, please explain to me how you're going to evaporate so much water on one side of the world and suck all the air out. Let me say here's the other thing. Most of that water would go with the air. It's going to also billow up. It's going to evaporate up and build up in that big cloud. most stream out and get sloughed away. So you got to evaporate even more water to make up for that. Well, you got to evaporate so much water, it's crazy. But there's no sign that Earth's had a net loss of water in this time. And we're going to show you other signs about this. So what happened here? Well, I definitely would say that we can have very large coronal mass ejections. The Charlemagne event is thought by some to have been 10 times more powerful than the Carrington event. And the Carrington event caused wires to catch on fire in telegraph stations. So, and in one event, a tenth as powerful as the Carrington event, which happened in 1859. There was a railroad event in 1921, which is only a tenth as powerful, that caused some trouble with wires and rail lines and rail stations. That's what it's called, a railway event. So there you go. You could have some issues, my friends. So what does all this mean? Means I have a hard time thinking that Doug Vogt got it quite right. Also, think about this. You ever driving along on a winter day and you look at a lake in a winter day when it's really cold in the morning and watch that lake. Look at all the vapor coming up out of that lake. It's evaporating. Things can evaporate when the water is dry. In fact, when the air is dry, actually, you're going to get a higher evaporation because the air is not as saturated. And when it's cold, hey, I've seen that water vapor on cold days. Well, the water's going to be warmer. So, you know what, this whole, give things a length of time, tens of thousands of years of snow that don't melt, don't run away, and it keeps falling year after year for 10,000 years, you just might get a 2-mile thick glacier. So there you go. Doug, I'm sorry, my friend, get your pencil back out and sharpen it some more and have another look at this. That's what I ask you to do. So, hey, but who am I? I'm just a rocket scientist. He happens to be a worm farmer and a prepper. All right, so let's talk about some more of this stuff. We're going to go and talk about, once I lay all this out, talk about bug out zones. I'm going to get my map up and I'm going to show you what's good and what's not for the Chan-Thomas event. So supposedly, this micronova, it drives Earth electrically. So you got the Earth spinning, and let me get the center right out. Here we go. Spinning east to west, and this big electrical field hits it. And Earth has, a dynamo inside, and it's a motor generator situation. So, according to this report, it shuts it off. Some think that at times the Earth goes cheap this way, not just stopping, but it actually gives a tilt. Some thinks it goes upside down. Well, the magnetic fields definitely switch polarization from ever so often, and that may cause problems. I've discussed that in the previous video, and we may come back to that. But what happens? Does Earth do this? Does it stop? Well, let's just talk first about it doing this. See, here's what you need to know. The Earth has an equatorial bulge. The equatorial bulge is 26.5 miles thick. 26.5 miles thick equatorial bulge, because it spins around this way and the mantle is kind of plastic. So you got a bulge in the center, sticks out 26 miles. So if the crust is slipping over that bulge, what that means is it's got to be like it's got going up the biggest roller coaster. You got to climb a 26.5 mile mountain, essentially. Mount Everest is 29,029 feet, which is just on the order of 5.49 miles. So it just so happens then that Mount Everest is, if you divide 26.5 by Mount Everest, you would discover that the equatorial bulge of the Earth is 4.8 times higher than Mount Everest. You think Mount Everest is high? Nah, forget about it. Earth's bulge sticks out farther. You didn't know about that, did you? I told you I was going to talk about geology, and we just started the geology part of this. So, but Greg, okay, so it slips over. Well, think about this. If Earth is slipping off the crustal continent plates and all these plates are slipping over that. They're long, big plates. How can they, how do they handle going over a big bulge like that? It'd be shattering and breaking because they got so much weight on them. It'd be shaking, shattering, and breaking. All these plates and crantons that the continents are made out of, the coastal plates, they would shatter and break. And when it shattered and break, the volcanoes would just vent and go crazy. It'd be the end of the world. You got so much volcanic activity. It would literally be the end of the world. And the plates would be all tore up. You know, all the caves would collapse. Everything would collapse. The winds would be obscene. Even if it went kind of slow, you know, you're still going to be breaking the plates. Unless the entire world wasn't just a crust slipping, the entire world did it. But then what would happen is your bulge would readjust itself, and so would the oceans. Suddenly you got 26 miles of ocean relocating somewhere else. Ah, but the continents might rise up too because they're all riding up on top of that bulge. But what's going to happen again to the plates? They suddenly got a new stress on them. They're getting shoved in the air 26.5 miles. Woo! Okay, some people think the Andes got shoved up in the air real fast. Maybe it did. See, there is the theories of geology. The old geologists, for, 100 years ago, thought and believed everything was gradualism. And all the changes in the world happened a millimeter at a time. And the Earth continent. Later, when they come up with a continental shift, they figured that the continent spread apart about the rate at which your fingernails grow. So. 26.5 miles. Yeah, I'm not buying that. So what happens if the Earth stops and it's, well, yeah, you would get the oceans come up out of the basin. We're going to talk about that, but I'm going to show you why. It's probably not as bad as Chan Thomas. If it does happen, wouldn't be as bad as Chan Thomas says. Now, I already confess that the strongest force is electromagnetic. It's far stronger than gravity. If you had a big enough current from the sun, it could shut the Earth down, but the effects of it would be unbelievable. Unbelievable. But we're going to entertain it, though, just for the purpose of discussion and bug out. But I'm going to shoot at it a little bit and show you why it's not been what Chan Thomas claims, and I'm going to show you where you can go to survive should it happen. So I'm going to promise you. So we're going to go back to sharing again now, like I said we would. Ding, 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 bang, bang, there it is. So here we are back at the Vostok ice core. And yeah, we talked about this guy, little boy. 2.8 trillion of these to evaporate 600 feet of water. Woo-wee. See, it's 15 megatons. Kilotons, excuse me, 15 kilotons. That's what you divided by. It's 15,000 tons. 15,000 tons is what I divided by to figure out it was 2.8 trillion of these guys going off. Ooh-wee. All right. So here we are at the younger. So we had this ice age, the Pleistocene. It ended. Things started warming up. And then it started cooling off. And then we had this event right here, the younger Dryas. So this is what Doug Vogt keys on. Is this? I don't know. I didn't key on that one, but this is it. So the younger Dryas is like the ice age came back. It was getting better and better for a good little period of time. Then it got a couple thousand years. It got really bad. But it was also dry and dusty. It was a really, 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 really bad time. And it warmed up, gave us a blip, and then we recovered. That's some big cold event here, that 8.2 thousand years ago. And we've had warm events. So here we are right here. This is us today. It was been warmer. Look at this. Real warm right there. What was that? I said 1, 2, 3. Well, over 3,000 years ago, we had a real warm little spell hit us. So everybody tells me, well, if it gets a little bit warmer than it is right now, it's going to be the end of the world. If you can't possibly get this warm, really. What do you think? Is that true? You think that? There's Mount Everest, 2929. In the year 2929. Yeah, it's not long from now. 2920. Yeah, it's a long time from now. 2029 is not. Okay. Another thing that kind of weighs against that Earth shift thing is if the Earth had shifted and stayed shifted for any time at all, this part of the ice sheet, mainly the East Antarctic ice sheet, would have melted. And this thing here is about 400,000 years old. Now, this is why Ben Davison said the Earth shifted. and it shifted right back to its original position. The original shift is kind of hard to stomach. The idea that it would shift back, not only shift back, but to the original position, not right exactly where it's at. That's even double hard to swallow. It begins to violate Occam's razor. You know, Occam's razor is only, you know, when you got several options in front of you, pick the easiest, most easy to explain. That's always going to be your answer. And in science, that's hard to find times when that's violated. So he has the world shifting. Oh, it's got to shift back so that ice sheet don't melt. Interesting, to say the least. Yeah, let's look at it. It's kind of like a triceratops, right? The horn, the big thing on its neck, the big shield. Get out of this thing. Hang on. Look at this. 65 million years of climate change. We are down here. Look how warm it was 55 million years ago, or 50 million years ago. By comparison. Now, some people think it'll get that warm again. Well, I don't know. Wasn't the end of the earth then. It would certainly been a lot. It'd been interesting, but it was even warmer than this way back here. And then the CO2 levels were also higher. Yeah, there's something you can find back in. You can look at the historical CO2 levels back in these ages when there's in the thousands of parts per million. The data's out there, but we shan't go into it today. That's not the topic of this video. Post-glacial sea level rise. Now, so 12,000 years ago, we were right about here. Now, see, it's been lower. This is the point where we rose about 400 feet from here out. But it's been much lower. I tell you, it's been like 750 feet below at one time, sea level. So Doug Vogt's event is roughly, you got to go 12,500. So you're looking right here. This, but look, it took place over some time to him all at once. Interesting. Well, that's the rising sea level. He saw it dropping and then coming. Well, I don't know. It's been rising since then. Okay. Yeah, okay. He saw what it would take to put he saw a solar micronova initiating the ice age. Okay, so his event was back here. Pardon me. It would have evaporated all this. So it would have had to evaporate more than 600 water feet. Well, it was like 750 years ago. Yeah. So I got it backwards. Pardon on me. So it's more like that is the beginning of the glacial, the warming. So it'd be on the other side when you start cooling his event. But it keeps dropping off slowly. That's what's a sudden increase. Interesting. This is a sudden part. The warming takes place in spikes. The cooling tapers off. And if you look at our most recent thing, there's also a downtrend here. All right. There you are. That is looking at some of this data. So Doug Vogt's event would have to happen on this side of the things coming down, evaporated water, cooled it down, and formed glaciers. So it'd be right over here. So he thinks we're going to have it in 2046. Diamond thinks we'll get it in 2042. What? Let me ask. I'm thinking of you. What do you think? I'm kind of thinking it ain't going to be what they said it is. But there's something going on. The Vostok ice sheets tell us of something. What is it? See, I think Doug was asking the right questions. I'm just not sure he got the right answer, my friends. So let's look at it some more. We're going to unpack this thing. Bam, bam. We're going to come in here. Here's your Adam and Eve story. This is the CIA.gov library, reading room, docs. This is what the CIA wants you to read. Why they want you to read this? They had this document classified for a long time, and then they disclassified it. Passions and perils of nationhood. And then it goes into the Adam and Eve story. He talks about great floods. Like Noah's 6,500 years ago, like Adam and Eve's 11,500 years ago. This too will soon come to pass. And he goes into his big story in here. I'm not going to go through the whole thing. No, if you're not going to read it. But here's what gives me faith. stalactites, stalagmites. You see, these things grow at 0.0051 inches per year. Okay? Think about that. They slowly trip, trip, trip. Throwing more water on them don't make them grow any faster because it's a chemical process. The chemical process has to take place. So over 12,000 years, this would be 61.2 feet. Oh, inches. 61.2 inches, which is only 5.1 feet, about 4 foot per 10,000 years. So since the last glaciation, we've only got glaciation ended. We've only got 5.1 feet. Okay. So I don't think, see, some people are saying this is happening. Doug Vogt says this event happens every 12,068 years. He said every 12,068 years we get a micronova. The Earth stops spinning, the oceans come out of the basin, half the ocean is evaporated, and the Earth starts spinning, and the oceans come out of the basins. Every 12,068 years. Doug, I think we're overdue. I'm going to dry us in about 12,500 years ago, maybe. All right, so what in the world have I got here? Is this what I was looking for? Oh, yeah, Cathedral Caverns. This is right just a few miles from me. Cathedral Caverns has the largest entrance of any cave with an opening that's 126 feet wide, 25 feet high. But inside the biggest room, there's this column. The column is where the stalactite and the stalagmite meet each other. This is one of the largest stalagmites in the world. I understand it's the largest. Measuring 45 feet tall and 243 feet in circumference. Yeah. Yeah. Now let's go back and look at this thing. So there's the entrance. Here's stalactites, stalagmites all in this cave. I've been here many times since I was a kid. They're 25 foot, 45 foot, all in here. Smaller ones, but this one's huge. This one. There it is. That is it right there. That's Goliath. And it's a big part of what blocks off the entrance of the cave with just narrow passageways, and it leads into the big room behind it, which is supposedly the biggest single room in any cave also. So it's a very awesome cave. There's also a shark tooth in the ceiling of this cave. Oh, great, that proves it. No, it don't. That just is when the Earth was covered with water there. So this is Cathedral Caverns in Grant, Alabama. Really close to me, really close. I can get there in about 40 minutes drive. And let's see. So let's look. Let's say Woodville. That's Woodville, Grant, depending on which way you go to get to it. Beautiful place to go. Now, so let's think about this. 45 feet. For a stalagmite to grow 45 feet would take 105,882.35 years. So over 105, almost 106,000 years. So let's say, Doug, let's expand and say we got a 12,500 year cycle. That would be 8.47 of those cycles would have hit this cave in that time, giving you 8 cycles. Greg, what does that mean? Why is that significant? Well, here's why. Let me pop out a share here for a minute. Here's one that's significant. A cave with stalactites and stalagmites in it, and you got a wave of water coming over. Water don't have to be that deep, just 100 feet or not even that. Do you realize that there are people that have cutting tools that shoot out a stream of water like a laser, and they cut steel with it. They cut 1 inch steel with water jets, like a water laser. They call it a water laser. You can cut words in it. You can cut steel plate. And people in submarines really understand. But you get a leak in a submarine, you get a jet of water cutting, shooting through. It's like a knife. It will cut you in two. It will cut stuff inside, and it will rip that hole up. You got to stop that water really fast, or you're in trouble. It's the same way with these caves. If the cave's got anywhere in them that water from the outside could come in, like the entrances of the caves, which they typically have, or air holes, or just porous ground, once that water finds a way to punch through, and that kind of pressure, it would find that weak point. It would punch into that cave. And once it shoots into that cave like a hammer, it's going to bust all these stalactites and stalagmites. And Cathedral Caverns is full of them. Stalactites far bigger than 5 feet. 100,000-year-old stalactites. I mean, that's how long it takes just to grow from top to bottom. But something to grow that big around, you're talking millions of years. It might have been a few different stalactites and stalagmites. It might have all joined. So some of these formations, and not only in this cave, but others, are millions of years old. What does that mean to me, and what's that mean to you for prepping? What that means is no Chan-Thomas wave came over Cathedral Caverns. Cathedral Caverns is a little bit lower in altitude than what I am, so I've had no, and I'm at 832 feet. There's been no Chan-Thomas wave pass over where I'm sitting right now. Didn't happen. Did not happen here. We might talk about how a wave might have got dissipated and why it did not come here, and where it would be good and bad places to go based on that. Okay, that's where we're going to go. That's when we talk about bugout zones in this video. All right. Hope you bear with me this time, because this is what it takes to get this story up. So I'm going to talk about where the safe places are, why this is a safe place for an event like that. Should you get a wave, and you could, why it's not going to come here. That's wrong. I'm not even saying at this point there's not a wave. I'm just saying it did not come here, and I'm going to explain why. Even better, right? Of course, the why might be it didn't happen. That's kind of what I'm thinking. At least not to that category, but it might have happened. And there's some evidence of waves, so I'll give them a little credit. But so where did Chan-Thomas come from? Well, they found some weird things, and he was trying to explain it. So we're going to talk all about that. We're going to unpack all this stuff. So hang on, let me go back to share and make sure I don't kill my video before I do this. It's the wrong button. Well, okay, so Greg, how high is safe? What level above sea is good? How do I know where I can go? Boom. Well, look at Florida caverns. Wow, these are ginormous columns too, from top to bottom, everywhere, and lots of them. And this thing's about 70 foot above sea level to the entrance of this cave. And so in the Ice Age, it would have been about 470 feet above. You remember me telling you that you're probably okay if you're 500 feet above sea level? Bada bing! Greg Allison knows what he's talking about. I said, you probably want to be above 500 feet above sea level. That was in my previous video. Now I'm backing it up with geology. This is 470 feet. Okay, it might have had 30 foot of splash. You know, a little water came out, but, you know, nothing to shoot in and cause the pressure to shatter all this stuff. Because look, it's beautiful. It's there. And this is in Florida. And there's similar caves in other parts of the world. All right, so what other reasons would I say that the wave may not have hit? Okay, there are evidence of waves or something scouring some places, okay? We'll look at that in a little bit. I'll go back to that. But boom, how about the pygmies? Do you realize the pygmies have been living in Central Africa, in these areas here along the Congo area? And by the way, there's no mountains or anything. This is along the equator. This is where your wave would be the tallest, the highest. And there's nothing for a wave coming up out of the Atlantic to stop them here. There's no mountain ranges. Yet the pygmies persist here. Not only that, but according to this Wikipedia site on pygmies, it says that they have been the ancestors of the pygmy hunting-gatherers and farming populations, talking about 600,000 years ago. It says they split the groups into the eastern and western pygmy groups 20,000 years ago. I think this is over 12,000 years, right? That's probably over 12,000 years. Oh, Greg, it's just one people, one place. Well, what about the Aborigines of Australia? Some people say they've been there 50,000 years, this article. Okay. Aborigines comprise distinct peoples who have developed across Australia for over 50,000 years. So what kept them from getting flooded? 50,000 years. Not only that, but there's animals all over the world that survived in places that they shouldn't have. But there's also animals that died in specific areas. We're going to talk about all of that. So we're going to go to the map. Bam! Here we are. And we're going to stay here for a while. We're going to stay on the map. So we have things to protect us in this country. Now, there is an area of the world where you seem to see what looks like it could have been a ginormous wave sweeping through. It's easier to tell on Google Earth. My Google Earth is crashed on this computer, and I'm probably going to take this computer and have it redone, so I don't see much point in reinstalling it right now. This is Google Maps. It's much plainer on Google Earth. You can see if you go in here on Google Earth and look at the Sahara Desert, it looks like this area just got swept out through here. And like some giant or something swept through. That could have been wind erosion. There's something called in Mali called the Eye of the Desert. You know, and some people believe that was Atlantis. And if you get looking, you can see that maybe there might have been 1,000, 1,400, 1,500 foot wave swept through here, it looks like. But then again, maybe it's just wind erosion because it is going up high. And if you had a wave like that there, why didn't you have one here? Why are the pygmies okay? Regular, we're living up in the Atlas Mountains. Well, maybe. It looks like they've been in this area this whole time. There's plenty of evidence of that, and it would have been kind of cold up there in the Ice Age, probably. Australia, where's the mountains at? They would have blocked all that stuff from sweeping across Australia and wiping out the Aborigines. How about down here? How about all the wildlife, all the big game animals, big game, listen to me. All the megafauna. The megafauna that exists in Africa and in Asia, that survived. Where did megafauna not survive? Europe and North America. Almost all the megafauna in Europe and North America were wiped out at the end of the last Ice Age. It was a major die-out, but it does not count as one of the 6 major extinctions or 5th major extinctions, according to the people that measure those things, the geologists and people that look at those kind of things. So that's interesting. So much death and it don't count. Well, here's what's interesting. I didn't bring it up. Let's search for it if I can. Carolina Bays. Let's put that in here. Oh, that's what I don't care. Oh, well. Should pull this up earlier. I can't type. So here's what's interesting, my friends. There is all across North America a pattern, especially evident in the Carolinas, and then we didn't really notice until we got looking at setup of these ovals, these impacts, and they occur all over the eastern seaboard and other places. And in an oval, you have 2 centroids or 2 centers, and they're along an axis. So like you can get the radius from here and here, and then you got a distance between them. That's what makes, instead of a circle, it's got one center point. This has got a line down the center with 2 endpoints for the radius. And so that's a major axis of the oval. So you can see it's got 2 centroids instead of 1 in the center. And all of these point back at the same point. So you got them in the Midwest and all up and down the eastern seaboard, and they all point to one point. You see that? Look at all this. Let's look at some of these pictures. I'm blowing up now. I'll blow them all up. Sometimes it takes you a different website and you see stuff that's kind of crazy. But look, There's also evidence of, so this is evidence of an impact. Of course, you know, the voting, a lot of people are out there saying, well, yeah, the sun crusted up and all this stuff got flung off the sun and caused these impacts. Something impacted here. See, Chan Thomas was looking at things. He found evidence of flooding at 10,000 feet. Well, a 2-mile thick ice sheet is more than 10,000 feet up. It's 11 to 12,000 feet at the center of this thing. So if you got a comet hitting right here over eastern Michigan, and it's throwing ejecta, where a lot of this ejecta is going to be water. You're going to be spraying water all over the blame place, not just chunks of ice and whatever made these impacts. You're actually going to be spraying water too. So yeah, that was the middle of an ice sheet. So you got real evidence of something hitting here right on top of that ice sheet and causing a major ejection pattern all around. See that? Been a bad day in North America. What would have survived this in North America? All kind of bombardment. You know, maybe it didn't show up too much in these other areas because it was covered with ice. They sure shut up all around here and here. So what happened here? Kind of curious, right? So this thing might have had a glancing blow. Maybe that's why it favors more this way than that way. When it hit, like it was coming in this way, for some reason a bunch of it got thrown out that way. I don't know what that was. That is what they find. But there's also another impact. It's not 2 impact points really. So you know, a lot of times comets will break up, so you get this. And plus we found an impact under the ice of Greenland also, as you may know. So also they're finding other evidence. Now this is when basically the Clovis culture died out in North America. And some people say the Clovis point didn't resemble any points coming from Asia, but is almost an exact point match for points in France that period. So some people postulate that the so-called Indians that lived in North America this time were actually Caucasian from Europe, but they died out. And the Asian Indians that came in from right after this are the ones that populated the continent and had it populated when Europeans came here. So yeah, this was a rough event in North America, and it was also rough in Europe. There was huge climate change and all kind of things going on. Survival became very problematic in the Northern Hemisphere at this point, especially in Europe and North America. So there you go. That's the Carolina Bay story. They tell us that something hit. And the something hit might explain a lot of what you hear in the Chan Thomas story. But let's go back to the map. Let's say, hey, we're going to get the floods. Okay, here's how you need to know this. We're going to unpack it. What happens if the floods hit? First thing it's going to do is hit the Cascade and Sierra Nevada mountain ranges right along our west coast. Now, it might come through in San Francisco where you're open air, flood to Sacramento Bay, and it'll probably come over these mountains and probably these mountains here. And then it hit all in this water, all this area here. This is a big basin. It does have an alley. You can run back out down through Los Angeles in time. But, you know, this is a basin in the basin. Now, I've been to Salt Lake City and all up and down through here, and you can see on the mountains around the Wasatch Mountains, you can see evidence of sea level, about 3 different levels, very high up, or not sea level, just water lake levels, like Bonneville Lake, as they called it, filling this whole area up. Did that come from a Chan Thomas event? Did the big lakes that used to be here all come from a Chan Thomas event? That's an interesting question. Or are there multiple ones out there that flooded all this? Well, I can't say no. So maybe Chan Thomas was partially right. But he thought this swept, he said you couldn't survive unless you were on the leeward side of Pikes Peak. Well, how many animals are you going to climb up to Pikes Peak and wait for a flood? Not many. Little ferrets, maybe. Are they right at the top, tippy top of Pikes Peak? I don't think there's anything other than people that would have the desire to do that. Maybe a bird. So yeah, this whole idea you had to be hiding on the leeward side of Pikes Peak to survive, that don't wash for for this flood story for me. It's a wash. Now, okay, let's say it hit here and dissipated in this area, but maybe it did. Maybe a little bit flowed over. If it flowed over, I would say it went down it hit the Mississippi River Valley and all went down the river. Why? Because the caves are intact all in here. You got huge limestone caverns, you know, in Kentucky, in Tennessee, Alabama, all through here. We got thousands of caves right here, up in here, Mammoth Cave, Florida Caverns, Cathedral Caverns. In fact, the National Speleological Society is headquartered in Huntsville, Alabama, on Cave Street because they got a cave there. The courthouse is built on a cave. We got so many caves in this area, it's not funny. And they've got lots of stalactites and stalagmites all through this area. So what I'll say safe from Chan Thomas area, bingo, right here. And probably the mountainous areas here too. So, all right, I'm going to draw Chan Thomas safe area. Well, but before I do that, we're going to look around the world a bit more. Who else is safe? What else would save people? These mountains here might have saved a few things down here in Mexico. I mean, hey, there was tropical animals and plants that survived. South America might have been well positioned, you'd think, because they had the Andes. The Andes is a real tall mountain chain. So maybe nothing broke through. So maybe South America would have been good in an event like that. If something did break through, it went down the Amazon. But why were the pygmies spared? Why was all the big fauna in Africa spared? Maybe it didn't happen. Why was the Aborigines in Australia spared, huh? Lots of good questions. But most of the animals and bird species that you find on the Pacific Island nations are only about 10,000 years old. So what happened? What happened? Well, I wouldn't argue that something didn't happen. What was it? It might have just been an impact. If we find Buckminster fullerenes and micro diamonds in the soil deposits of that area all over the world, including where the Clovis Point was found in, I believe it was New Mexico. So we find these things. They are multiple indicators of an impact. And I would say that the diamonds and the Buckminster fullerenes are pretty much evidence that it was either asteroidal or comet, not crust thrown off from the sun. So if the sun's going to go into micronova because it crusts up with, we'll go in that minute. In fact, let me stop the share. We'll come back to this. So the theory is that the sun just crusts up. It accumulates the stuff on it from dust from space. And like, do we find through a major dust cloud? Do we see evidence of the sun crust up? Some people say, well, the sun went from being yellow to white. Well, that means it's burning hotter. You know, if it's crusting up, it ought to be turning redder. You shouldn't be able to see it as much. If it's about to go off in a micronova in just a few years, you know, a couple of decades from now, 2.5 decades from now or less, you ought to start seeing some sign of the sun crusting up. Instead, we're finding coronal holes. We're finding openings. And the sun's getting whiter, not redder, according to some. Where's the red? The sun takes some Visine, get the red out. So yeah, because there'd be more heat, less light coming, because you're being blocked. It'd be the heat, but you wouldn't get as much light. So the sun should be looking redder and redder. That would be a warning sign. But why is it that the heavy, the sun's made out of hydrogen? So how is it you get this thing made out of hydrogen? It's got silicons floating in the atmosphere. Aren't they heavier? Yeah, shouldn't they be sinking? Going to the core of the sun? Think about that one. So how does the sun crust up? All right, maybe somebody can explain that. Whatever. That's not the point. All right, so here's my point. I'm going to make funny. So if all this happens, how do you survive? One, if you get this event, kiss yourself goodbye. I said, don't be at the wrong place at the wrong time. Planet Earth would be the wrong place. The inner solar system would be the wrong place. You'll be way out somewhere living inside a hollowed out asteroid. Now, if you dig down 1,000 feet underground on the cold side, you might make it. Well, actually, you probably wouldn't have to dig down that far, but you know, all the atmosphere would be gone. You know, once you open the chamber, you'd die. You got nothing to breathe. All right, let's ignore that. Let's say, oh, okay, you can breathe. All right, where would you go? Where would you want to be? Over here. Underground in a pressurized container. Well, I've got the idea for the underground portion of my universal habitat. That's the absolute best habitat concept to survive these kind of things, except for a deep underground base, maybe. Yeah. So, but you know, if the Earth is shifting, you know, if all this stuff is happening, if the Earth just stops, if the crust stops moving, the momentum, the change in momentum will be horrendous. It's not just the winds that's going to go sweeping. You got that all momentum in your body. You're traveling, if you're at the equator, you're going 1,100 miles an hour around the center of the Earth. A little bit less because we're farther north. But suddenly, if the Earth stops, you got that momentum built in you. You're going to smack into the wall. In fact, that's what's going to happen to all them. It's going to smack into rocks, walls, trees, whatever's out there. Hard. Just imagine if it stopped all at once. Imagine taking your body and throwing it 1,000 miles an hour into a rock wall. What animals will be surviving that? So you need to be in a rubber baby buggy bumper suit underground and hope the cave don't fall in. Oh, my habitat won't cave in so bad. It's going to be more resilient for that, and have dirt overhead for thermal mass, so you can survive a lot of this stuff. So my universal habitat's a great idea. I'll be talking about it more in the future. So I would submit that we never had an event on Earth in the last several million years, or since multicellular organisms arose. There's never been or came to this Earth, created, however you say it. I do believe in intelligent design. I do believe in greater creator. But how do you get a time and a point that you get that kind of evaporation and things survive? I don't buy it. I think there's a little different explanation than, well, 600 foot of seawater went poof, evaporated. You know, it was a bit of sun, and then everything went poof. No, I ain't buying it. Sorry. It's just, I'm having a hard time swallowing that one. Really hard time. I want to say absolutely it didn't happen. Well, I'm pretty close to that. I'll say it didn't happen in that fashion. In fact, I'm skeptical. 99.99.99.9 I ain't expecting that. But should the Earth go, I got problems with that too, because maybe it did a little bit slower. I'm gonna tell you, you can get thrown on the wall, my friend. Caves will cave in. You wouldn't have a cathedral cavern. It's just that sudden jerk and momentum of the Earth's crust would shatter every cave. They'd all cave in. I'm not worried about the jet of water coming inside, smashing the stalactites and stalagmites. That's what happened if the cave didn't cave in. The caves would cave in. Those kind of stressful, especially if it went over the bulge, you know, your caves would shatter. Everything would shatter. Mountains would shatter. Shatter and chatter. All right, so let's go back to our screen share. Go back to Earth. Come out. Okay. So what are the safe zones? Let me get our pen. For, that's weird. Annotate. So if I can draw again. Give me a second. I want the eraser format. We want to do it, and we're talking about survival. We want green. There's the pen. So if you're just in case the water splashes over the Rocky Mountains, it ain't gonna be as much because this is gonna stop a lot of the water, and it's gonna start dissipating as it goes over more and more of these mountains of land. Maybe some of it washes through anyway. The areas that are higher in altitude are going to be the safe spots. Those arcs, for example. But then again, hey, we got a cavern down here. But like I said, I would stay over 500. I'd stay above the fall line at least. I'd say if you're in this area, with regards to this stuff, you're probably good. I wouldn't want to be around Atlanta no matter what. And I would draw exception circles for, the big cities in here, like Birmingham, especially. So if you don't figure in the reactors in the area, which are down here, this might be a special good safe zone for a Chan Thomas type event. Pretty much anywhere over here, honestly. So remember, I did draw the Mason-Dixon line basis. You don't want to be north of that; it's going to be too cold. But down here, in these areas, where you're above enough altitude, there's no evidence that this seawall ever came through here. The evidence says no. I'm not going to say it didn't hit back here. I'm going to say it didn't come here. So what else would be good places? Let me go back to mouse. Oops. Eraser. Start mousing around. We don't need all that. Mouse. I would say this may not look so good. The Atlas Mountains would be good. So right in this area would be good. The Alps would be good. Probably some of these mountains in this area would be good. That would be good. Maybe Scotland. If you get enough altitude away from the sea, Norway and Sweden. Yeah, I need some coffee. And just get to Ural Mountains around here. So I would say Moscow would probably be safe. Yeah, my old buddies in Moscow. Let's not give me my pen back now. Oh. Oh well. Well, okay, it's not really, pen's not coming back to me right now. Some strange reason. But in essence, you got the Ural Mountains here. So if you got a big wave sweeping through here, it's got to sweep across a lot of territory before it gets over here. So Moscow might be safe. I'd say you got mountains all in here. So around the Caspian Sea might be this whole area right up here. For the Moscow, all this area right in here, this area will probably be safe. Well, the Caspian Sea would probably come up out of the space and then over this way, maybe fall back down. You got a lot of mountains in Iran, Afghanistan, Pakistan. So, in terms of ocean flooding, those are probably safe areas. In terms of people going banging each other, maybe not so. Of course, the Himalayas would be good. Yeah, well, if the waves going that way, they might be all right over here. I don't know. So there you go. And look, where people been surviving forever? Here in Africa, for some reason, and Australia. Okay, I believe we've covered it. This video's gone long. I'm probably gonna have to post it tomorrow now. It's just been too long in recording, but you wanted to know about the Chan Thomas event and micronovas, or really micronovas. They kind of have been by some people thrown together in one discussion. And they have a lot of fans of this. And, you know, I like some of these people. I know I've met a couple. And so I'm not trying to disparage upon them personally. I'm just saying that Duck Boat needs to sharpen his pencil a little bit. Maybe he's explained it, but you know, I'm just having a hard time swallowing all this stuff. When I look at the geology of the world and see areas that show no evidence of some of these things happening there, I get a bit skeptical. Okay. All right. Let me end this year. So there you have it, my friends. I just gave it to you based on the biology that megafauna is still in Africa, megafauna is still in Asia. Megafauna, the equatorial megafauna of Africa survived. The the pygmies, the aborigines, they all kind of weigh in against this Chan Thomas thing, especially given where they're at. That's areas that you would think a flood like that would hit. There's some signs that might suggest a flood in northern Africa. There've been asteroids off the coast. How would you get one up there and not have one on the equator, where the bulge is bigger? So you think to stop the world from spinning, that would go kicked up even more. I don't know. So a lot of things to consider here, but the key thing is this: you need to be somewhat underground. My universal habitat accommodates that. Earthships do. Or you can build an underground home. Being underground helps in these kind of things. But even if you can't do that, put some thermal mass around them, sandbag it or something. You might think about that. But the key things is here that you just need to know you need to get ready for all kind of things that can be coming at us. Well, I am expecting there may be there's at least a magnetic pole of excursion going on right now that could affect our electronics, even our power grid, and our lives down the road. We don't know fully right now. Our shields are down. That's what it really means. So if the sun stays weak, we might be fortunate during this time, but if it kicks a big one off and hits us, we can be in trouble. So bear all these things in mind. And I'm going to end the call now. So say, Greg, I know where the floods aren't going to hit. Right now, the best place I can tell you is right here in the southeast, because we got the caverns and I know it. But I also know that Africa's done pretty well. Australia's done pretty well. New Zealand, as mountainous as it is, yeah, it's got oceans would definitely, you think, hit it. But it's definitely got the mountains down here in New Zealand. So if you can get high enough, you're probably good there. Russia, Caspian Sea area, the Nordic lands, if you're in high enough elevation, the Alps. These are all good places. You can probably go, maybe in with Heidi. If you're on the West Coast, if you get really high, I did a video with Rex where we were pondering this. We found a valley that was about 10,000 feet in elevation in Colorado, southern Colorado, in which you had one of the slopes in this valley faced south, which I thought that was an ideal place to build greenhouses. So if it got super cold, you could survive right there in a way. And you had a Chan Thomas flood. So it's all things to consider. It's midnight here now, so it's already the 22nd of November. So it's just after midnight. I'm not going to be posting this tonight. It's already tomorrow. So I hope everybody enjoyed this video. They said, Greg, I think I know where to go. I know you watched it this long. All right, my friends. I hope that helped. I hope if nothing else, it kind of dispelled some of your fears about micronovas and Chan Thomas. Even if they were to happen, that's a few decades from now. We got a few other things to get rid of and take care of between now and then. So I prefer to focus more on what's in front of us. And we'll just have to figure that other stuff out down the road. But I'm not really personally concerned about Chan Thomas. Not where I'm at. Now, if I lived on the West Coast, I tended to believe this stuff. Well, I don't know. And again, what about Africa? What about Australia? You know, Oh, South America. You in South America? Good. Got the Andes. Unless you're on the western side of the Andes. If you're in Chile, no. Ecuador, Peru, only if you're up in the Andes. So there you have it. That's how I see it. That's what I'm seeing here and why I see it the way I see it. You're free to disagree. I won't take it personally. You can comment below. I'm sure a lot of people will get mad at me. Oh my God, Greg, don't you know that electricity is the most powerful force? Yeah, I'll tell you that. I've said that all along. But that don't mean that everything they claim happened the way they claim it happened. Okay, that's my point. So I believe in the power of electricity. I believe in the power of power. I'm an electrical engineer, for Pete's sake. Anyway, everyone, I hope you had a good time watching this. I hope it was informative. I hope it dispelled some of your fears, but I gave you more sense of practicality about prepping. If it should happen, I just showed you where the best places to go, and that's what I promised you. All right, everyone, it just took a while to build the case up so you'd understand what I was going for. Sorry about that, especially for those of you that aren't even watching now because you're short attention span. The reward comes to those that stay to the end. Change. Let's say that in your comments. The reward goes to those who stay to the end, or hang out to the end. The reward goes to those that can hang out to the end. Something like, I don't know. Anyway, some variation. Anyway, thank you, everyone. Thank you very much for watching. Have a